All right, my name's Cody Hill. I work for Platform 9, and Platform 9 is a software as a service company, and we like to call ourselves an open source as a service company. So we take difficult open source software and host it as a managed service. The two top products in that is managed OpenStack and managed Kubernetes. And when we got started in 2013, logical choice was swipe a credit card, get going with Amazon, and start hosting those customer control planes in the public cloud. Fast forward to 2017, so 4 years later, we realized that, wow, this is really expensive. And the value that our OpenStack cloud and our Kubernetes cloud is doing for our existing customers, we need that, right? Because we need to be able to cut costs and run more efficiently. So that's what kind of started with this. So the big problem that we had was that what we had budgeted for our hosting, we were spending about 157% of that, right? So it's kind of a big issue. The CEO is none too happy that we're spending more money and wanted to get those costs down. And what was happening was from 2016 to 2017, our customer base tripled. But our cloud spend more than tripled, not quite quadrupled, but more than tripled, right? So the customer base was growing here and the price of cloud was doing this. So we needed to figure out how to stop that. One of the things that added to this was not being able to choose the correct size instance for our workload. We had a goofy mix of CPU to RAM ratio that just the public clouds didn't have a t-shirt size for that, so we were having to over-provision either on CPU or RAM, depending on the instance that we needed to provision, which then drives up cost, right? So that was something else that we kind of wanted to solve. And so we got in a room, put together a list of requirements on if we're going to try to exit the cloud, what do we have to do, right? So this is the list of requirements. So the top thing, of course, is security, right? We're a SaaS company. We're hosting customer control planes, so security's top of mind. So if we're going to be leaving Amazon, Amazon has a lot of good security measurements and a lot of good things to help keep us secure. So that was the number one thing on the list. And then second, of course, was cost. That was the whole reason for looking for another solution. If Amazon was free, we would stay there forever, right? So, but they're not, and so we definitely needed to reduce cost, and not just reduce cost, we needed to reduce cost by at least 33%, or it wasn't worth the effort of moving, right? So we needed a pretty large reduction in cost in order to make it worth moving off the cloud. The next thing that we put on the list was we wanted everything self-service and automatable. We didn't want to have to put in a ticket, wait for a network team to get back to me, get a server racked and stacked manually, and do all the things that when you're running a data center takes a lot of time and effort, and there's a lot of wait states in doing that. And we didn't want any part of that. We really liked the agility that Amazon brought us, and we didn't want to really take a step backwards when it comes to the agility that we had and the way to grow. And then we wanted low maintenance infrastructure. So if we were going to go to a bare metal provider or something like that, we didn't want to be doing our own firmware upgrades. We didn't want to do BIOS configs, building operating system images, all of the stuff that you have to do when you run a data center. We just didn't want to do it. We didn't want to staff a team to do it. We didn't want to have to roll over the colo at 2 in the morning because our RAID controller died. But no. So those were kind of our list of how we graded solutions. And then no matter what solution we chose, they needed to have certain technologies built in, right? So for servers, it's pretty easy, right? We needed the mix of CPU and RAM that fit our workloads. So pretty simple requirement there. For storage, we knew that we were going to be using OpenStack and Kubernetes. So we needed a Cinder-compatible storage array as well as a Kubernetes-compatible storage array. And we didn't want it to be a big monolithic array like an EMC or a NetApp. We wanted a scale-out solution, right? So we wanted to be able to roll in new blocks as we grow. As those age off, you take the old blocks out and be able to kind of grow with this storage. And then from a network services point of view, we needed to be able to do firewalling, BGP, VRRP, all of the things that give you a highly available edge network we wanted to be able to have control to do all of that. So those are the things that we were putting into this evaluation. And then we started evaluating a bunch of vendors, right? So while this builds, we evaluated a ton of technologies. This is a small subset of them that fits on a slide. And some of these companies we were able to eliminate based on looking at their white papers without having to interface with anybody in the company. Others we actually went through full-blown POCs and kicked the tires and tested things out. And not only this, we also tested the ones that are not on this list are all three public clouds, right? So if we're leaving Amazon, maybe Azure or Google could give us more efficiency. And the answer was they couldn't get to the 33% reduction. Something else that we evaluated was trying to utilize the spot market and time and run our workloads and move them from instance to instance using the spot market. And the engineering effort involved in doing that was non-trivial. And then we also evaluated VMware because they're the 800-pound gorilla when you do virtualization in cloud, and if you're going on-premise, you kind of have to look at them. And none of those solutions also fit the bill for us. So the ultimate solution that we chose was, of course, Platform 9 for the management layer, right? So we're Platform 9's doing the OpenStack and Kubernetes management. We're then using servers provided by Packet.net. And then from a storage standpoint, we chose Terre because Terre fits that scale-out model. They fit the 33% cost reduction. They're very cost competitive. And they're OpenStack and Cinder, or OpenStack and Kubernetes compatible. And then for the edge network, we actually chose ViOS. It's an open source software router slash firewall, and it does VRRP and BGP and clustering and high availability and all the things that you need from an edge network. And it's actually a fork of Viata. Viata was bought by Brocade, and they closed sourced it. So ViOS is a fork for the most recent version that was open source of Viata, and now it's running as ViOS, and it works great. So a little bit about these technologies, right? So Packet is a bare metal as a service cloud. So think Amazon. When you get a virtual machine from Amazon, what do? You hit a REST API or a web UI, you pay by the hour, you destroy it when you're done. All of the nice things that cloud gives you. If you need to add storage, you provision that and attach it to the instance. You get all of that, but Packet is bare metal. So you're getting a physical server. Takes about 8 minutes to get a server up and running from Packet, right? So you can get a bare metal physical server, do your own containerization or virtualization. And that's what kind of allowed us to get the more efficiency out of this environment. Instead of getting VMs from AWS, we did our own virtualization using OpenStack. So that's kind of Packet in a nutshell, and you get all the things that you would expect from a cloud. You get Cloud Init and REST APIs and Terraform and Ansible integration and all of that stuff. And this is kind of a competitive slide that Packet provided, but really this is what they're saying is you don't have no lock-in, there's no proprietary technologies, you're getting bare metal servers. You're not sharing them with anybody, they're your servers, you get all of the resources out of them. And if anybody's taking pictures of slides, this is a good picture to take. If you want to test out Packet, they provided a promo code for us, so packet.com/promo/platform9. You can get $25 in free credits at Packet. And they have servers that start at like 5 cents an hour. So 25 bucks can go a long way to spin up a bare metal server, test it out, play with it, kick the tires, see what it can do for you. Terre. So again, Terre fit the bill for us, right? It was a scale-out storage array. It has Cinder and Kubernetes compatibility. And the cool thing about them is they're very cost effective. And the way that they get this cost efficiency without sacrificing performance is they have 3 tiers of storage. They start with NVDIMM or Intel Optane, which is basically RAM. You're committing all of your writes to RAM. That then synchronizes across a 40 gig backbone to the other system, and it acknowledges the write. So you're getting sub-millisecond response time from your storage array. It then tiers that down to NVMe, so pretty fast to unload that RAM into NVMe. and then tiers that down further to spinning disks, and does a lot of caching and all of that, so that you're mainly reading from NVMe almost the whole time. So cool solution. It's a scale out forever type thing. They have the deployments out there that are over a petabyte in size, which is more than enough for us. So good solution for us. So we chose those guys. And then Platform 9, right? Of course, our company. And one of the big reasons that this fit us so well was that we were already used to consuming RESTful APIs from Amazon. Our deployment model to deploy on top of Amazon consumed the Amazon APIs, used the Boto 3 framework with Python. And so retrofitting our provisioning platform to OpenStack was really easy. We're actually already running QA pipelines on OpenStack. So, but what Platform 9 bought us was, instead of doing DIY OpenStack and building a huge team that's installing and upgrading and maintaining and patching OpenStack, is Platform 9 does that as a managed service. So they do the installation, monitoring, troubleshooting, and upgrades. They do the same thing for Kubernetes, and we're starting to migrate a lot of our components off from VMs into Kubernetes for our customer control planes. So made sense. They provide that as well as part of the platform. And then one of the other things that Platform 9 does is they provide a OpenStack API to the public clouds. So you can consume Amazon resources, Google resources, and Azure resources using the OpenStack API, OpenStack CLI commands. So if you're trying to build a multi-cloud environment and you want to standardize on one API, Platform 9 provides that. And that's open source. It's called Omni. That service is called Omni, and it's open source. So we did that migration onto our own infrastructure, and some of the things that we didn't know we would have to really spend a lot of time and effort on are, whoa, loading. That didn't work. Wow, that slide's gone. Okay, that's interesting. Let's do it this way. All right, here's the slide. It's not quite as nice, but it at least works. Was monitoring. We didn't know how much monitoring we would have to do, and log aggregation and all of that, running OpenStack and Kubernetes in production. Oh, you're presenting to everyone. This is interesting. Let me stop presenting and then start presenting. Oh, there it is. Let's see if this ever loaded. No, it didn't. Okay, so we'll go back to this. So we had to build a pretty robust monitoring stack in the environment. We started with Prometheus. Prometheus is the new hotness when it comes to monitoring. It's really cool. It runs on microservices. With Prometheus, Alert Manager comes with it. So whenever you build a query in Prometheus saying, hey, CPU's high, disk's high, something's high, Alert Manager will alert you. So we have Alert Manager tied into Slack and VictorOps to notify us if there's some issue. We then visualize this via some TVs that we have in our ops area with Grafana. Grafana also has a Noki plugin, so all of the OpenStack metrics from all of our virtual machines and disks and networks and all of that can be pulled in from Noki. And then for log aggregation, so if something happened, something went wrong, we need to look at something, we have the EFK stack. It's not the ELK stack because we replaced FluentD with, or we replaced Logstash with FluentD. But we have that stack for nice visualization and searching of logs. So this took a lot more effort than we thought it would, building the right metrics, tuning them, getting the alerts set up to manage that bare metal infrastructure to make sure it all ran smoothly. So that was one thing that took a minute. The next thing that was a big issue for us was we were heavily dependent on Amazon RDS. So one of the good things about the public cloud is they have all of these awesome services that you can just tie into and use, and it's super easy. One of the bad things about the public cloud is they have all of these services that are really easy to get trapped in. When you want to move out, you need to figure out a solution. So one of the things that we could have done was gone back and just provisioned MySQL clusters using either MySQL clustering or Galera clustering or some type of solution like that. But we didn't want to get back into doing that. A lot of us on the team had done that in the past. It's a pain. You really should have a database team or at least a guy on the team that's really focused on tuning and tweaking and all of that. And that was one of the bigger asks from a lot of our customers was, we want a database as a service solution. So we went out and looked for open source database as a service solutions, and one of the only ones out there was Trove from the OpenStack community, and it wasn't really maintained anymore. It wasn't really kept up. We talked to some of the developers, and it was bought by Stratoscale and wasn't really kept up anymore. So we decided to build one. Anybody here familiar with Kubernetes operators? Yeah, one. Okay. So Kubernetes operators are basically one of the things that you can do is put all of the business logic that you would put into being a DBA, right? If my CPU goes up to this threshold, I need to scale out my environment. If RAM goes up, I need to scale my environment out. If I'm hitting a connections pool limit, I need to increase that. I need to increase the number of threads in my database. There's all kinds of things that if you wrote a run book on being a DBA, like if this, then that, you can build that into a Kubernetes operator. So what we decided to do was take an open source fork of MySQL called Persona, which is kind of like MariaDB, which is a fork of MySQL, right? It's just another one. These guys do a really good job. One of the things that they do really well is hot backups of MySQL, so you don't have to take the database offline, which is nice. So we take that, containerize it, put it on top of Kubernetes, do those hot backups to an object store of your choice, S3, Google, any type of object store, and then build all of that operator logic into this operator so that you hit a REST API and say, give me a database, just like RDS, and you use it. So this is something that we're building internally. It's running for us internally, and we plan on open sourcing it and giving it back to the community to have an open source database as a service solution. So yeah, that's cool. So that's something else that was a lot of time and effort and engineering that we had to do. And the finished product, right? So we have a multi-region cloud. We're using Packet.net. We chose 2 of their regions, one in the west coast of the US in Northern California, the other one in the East Coast in New Jersey. And we have about a terahertz of processing power, 3.4 terabytes of RAM. Not a huge environment, but big enough for us. So this lets you know that you don't need to be a giant environment to save money by exiting AWS. And we have multiple availability zones in their environment, right? So we have our servers spread across multiple racks. And so if we lose an entire rack, our environment stays up. And we have high availability enabled in this environment. So if you've ever used VMware or Hyper-V's HA capabilities, where if a VM or a host goes down, the VMs magically just go to the remaining hosts, we built that into OpenStack and open sourced it. That's something we have enabled here. So if, God forbid, a hypervisor goes down in the middle of the night or an entire rack goes down, all the VMs will be powered on the other remaining systems. And this is happening again. So let's, apparently, this is great. Stop presenting. Present now, your entire screen. Right? Okay. We need the high availability to kick in. So we'll just wait for this thing to paint. It should paint. There it is. It looks better in full screen, but that's okay. So this is a kind of a diagram of the way that we built out our network in Packet. You could see that at the top here we have a separate cluster. This is our network services cluster. And these are 2 hypervisors that are running those virtual via OS routers. They're doing BGP peering to packet, and then they're clustered and doing VRRP downstream so that we have a single gateway to connect. And all of these systems are connected through that layer 2 gateway, through VRRP. And then we have a bunch of sidecar VMs over here. We have our the edge routers, right? That's Vios. Then we have our name servers, right? So we're hosting, DNS. We have DNS resolvers or recursors. And then we have our Glance and Cinder OpenStack services that are basically orchestrating the back-end storage and back-end image libraries on the Terre array. So these are just some VMs that just say you need storage, it's on Terre, and connect it to that server. So these things just do an orchestration. And then these are all of the compute nodes. In the production site, we started off with 12. We're up to 16 now. They're new Skylake systems, and they're all running OpenStack Neutron with DVR and Nova services. So full distributed virtual routing in this environment. Works pretty well. We've actually have higher uptime now in our environment than we had in Amazon. In Amazon, every so often we'd get an email saying, hey, this VM needs to be powered off and powered back on in order to let it continue running because we have to do maintenance on the hypervisor and apparently we can't move it, which affected our uptime for that. So running this way, we have live migration set up, we can move VMs around, and we haven't had to take anything down like that, which is nice. Let's see if I can go back here. No. Come on. I think that's it. Questions? Oh, while he gets the mic, the results of all this, right? Hey, you did this. You exited the cloud, right? So the goal, sure. If you remember, the goal was 33% cost reduction. We ended up with a 67% cost reduction, I believe, and that includes hiring 2 people. So we saved a significant amount of money by moving out of Amazon. Questions?
Great presentation. Does Packet provide networking services that have an API, or were you required to build your own load balancers and networking stack with Vios?
Yeah, it's a good question. So Packet is pretty cutting edge when it comes to the networking side of things. They run everything layer 3 and expect you to do BGP in the environment, which works extremely well with Kubernetes. So you can run Kubernetes and do BGP peering, run MetaLLB, Calico, all of that, and you have a fully highly available environment out of the box with Packet. If you're running an older software stack like VMware, like OpenStack, something like that that doesn't understand layer 3 networking with BGP, you need to create your own layer 2 networks. So they have a REST API that'll give you VLANs. They'll let you bridge a server doing layer 3 one way and layer 2 the other way, and you need to set up your own edge. So that is something that they're working on. It's they have the REST API, the skeleton of the REST API built out and the UI built out for internet gateways. So they are going to be coming out with internet gateways that'll, I think, essentially do what we did with Vios, but it's not in production yet. Mm-hmm.
I have a question.
Sure.
It's actually 2 questions. One is about storage,
Mm-hmm.
how it's like price efficient, how they licensing volumes. And second question, Amazon, everybody think Amazon is cheap, but bandwidth, it's not cheap.
Sure.
And how you save on bandwidth using Packet?
Yeah, so I'll answer the second question first because it's pretty easy. Packet also charges for egress bandwidth, but it's less than Amazon charges. So that's nice, right? So right off the bat, just moving your data and serving it from Packet, if you have heavy bandwidth charges, it's less. They charge less. The first question on how Terre licenses, it's all based off of capacity. So I think we bought 125 terabytes to start with them. They don't charge you for they don't care if it's all flash. They don't care if it's all spinning disks. They do support all flash, by the way. They don't care. They charge just off of capacity, and it's an annual subscription.
So, and with the Terre, that's for physical nodes that you deploy, or was that as a service?
So for us, it was as a service because Packet provided the Terre hardware.
Okay, so Packet kind of helps resell that. Or
Yeah.
They host Terre, and then you can just add on storage.
Right, yes, they have a good partnership there. And they have two models.
Kind of like a department store for data.
Yeah. So Packet has two models to resell Terre. You can buy it from their shared pool of they have their own storage backends that's hosted by Terre, and you could buy capacity ad hoc by the gigabyte per hour, or you can get a dedicated Terre unit. We chose the option for a dedicated unit to get access to all of the Terre REST APIs. If we buy it from Packet, we have to go through Packet's REST APIs. And at the time, they didn't have a Cinder driver, and I don't know if they do now.
Okay, and you were using Terre for block storage exclusively?
Block storage and glance backend, so images as well.
Cool.
They also have an S3. They use Minio. They'll spin up a virtual Minio environment and give you an S3 compatible API.
Cool. Any more questions? One more.
So based on this model that you just presented, what percentage were you guys able to migrate off of AWS? Was it like 100%? And since you're on the new model, how dependent are you still on AWS services?
Yeah, so the only thing that we're dependent on AWS for is, I mentioned before that our product integrates with AWS. So all of the test dev QA that we use to test our integration with AWS is still running there because there's not a good way to simulate that, I guess, right? And not only does our OpenStack product talk to the AWS API, so does our Kubernetes product. We have a very tight plug in your AWS credentials and automatically spin up Kubernetes clusters. So all of that test dev QA still happens there. But I think that was like 15% of our total bill was test dev QA in that way. So we've basically set them up that they have $50K a month that they could spend on test dev QA, and if they go above that, then the credit card maxes out, I think. I don't know how we manage that, but they have a budget of $50K a month, and they haven't gone over that.
Hey, Cody, thank you. That was quite an awesome presentation.
Thanks.
Very interesting. A lot of